Hi students, welcome back. So in the previous video I explained about the segmentation. Now let us see the segmentation architecture and with an example. So then you'll understand what exactly the segmentation will perform in the concept of logical address and the physical address. So I explained that the segmentation is always the segment will store in the logical unit. So this logical address contains two tuples. So that is the segment number or the name and the offset. So actually this in this segment architecture you are having the segment table. It maps two dimensions. So that is a physical address, two dimensions of the, let me write that point. Segment table maps two-dimensional physical address. So the segment table maps two-dimensional physical address. So each table entry has one is base and another is limit. So the segment table consisting of two address space. So that is one is a base and another is the limit. So the base is nothing but it contains the starting physical address. Base contains, so just remember these terms, the base, the limit, which are the terms that are present in the segment table. Base holds the starting address, contains the starting physical address. So where the segment resides in memory. So in this starting physical address, segment resides in that memory. And the limit consisting of specifies the length of the segment. Specifies the length of segment. So just remember this, the segment table. So this is a segment table. This segment table consisting of base and limit. So this base holds the starting physical address, so in which that segment is resides, and the limit mentions the length of the segment, length of segment and address of segment. That is the starting address of the segment. So this completely you call it as a segment table. Okay. So now let us see the segment table base register. So here you are having some terms in the architecture, that is the segment table base register, that is STBR. So what STBR means? Segment table base register. So it points to the segment table's location in memory. So exactly it holds in the memory you have to store the data. So this segment table base register, so whatever I said, the base limit, so this is the base and this is the limit. So this base register, segment table base register, points to the segment table location in memory. And whereas segment table length register means the limit. I am talking about the limit. Length register. So that is STLR. STLR means segment table length register. So it indicates the number of segments used by program. Indicates number of means the length of the segments, indicates the number of segment used by program. So you have to remember that the segment number, that is the name, the segment number S is legal whenever it is legal if the segment is less than segment table length register. So whatever the segment that you are storing in the table, that segment should be less than the total length of the segment table length register. Okay. Now let us see the example of the segment table segmentation. let me explain the example of segmentation. So let us take this is the user space, and here you are having the segment table, okay, and here you are having the physical memory. So the physical memory, just take, and here you are having this segment table, that is the limit and base. So limit holds the length of the segment and base is the starting address of that physical segment, and you are having the segments. So let us take different segments. So let us take the subroutine, stack, square root is one of the function, like and let us take the symbol table and main program. So let us say this is a segment 0, segment 1, segment 2, segment 3 and segment 4. So this is completely the user space that you call it as a logical address space. So the logical address space consisting of all this segment name plus the offset. So these are the segments. These segments will store in the segment table. Segment table. So the limit is, let us take suppose the length of that one segment, that is a segment 0. The segment 0 length is 1000 and the base address, starting address is 1400. Okay. And the next, the length of the segment square root is, let us take it is 400. And the base address, the starting physical address is the 6300. And the segment 2 limit is 400 and the starting address is 4300. And segment 3, the stack, length of the stack segment is 1100 and the physical base address is 3200. And segment 4, the symbol table limit is, let us take it is 1000 and the base address is 4700. Okay. So each segment is having that address, starting address of that, means to where it has to store in the main program, means physical memory, and the size of that segment. So this complete user program is divided into set of segments. The first, whatever the program that I have written, that will be divided into set of the segments that will be stored in logical address space. So each segment is having some length, means the size of that segment, and the starting address of that segment. Now let us come into the physical memory. How it is stored in the physical memory. So first, segment 0. So the segment 0, so the base address, the starting address of that segment 0 is 1400. So this is the segment 0. Then what is the size of that segment? The length of that segment is 1000. So 14,000 plus 1000, 2400. So the segment 0 stored in this location. Now coming to the next size is 3200. That is a segment 3. So let us take the segment 3. The starting address is 3200 and the limit, the length of that is 1100. So just add 1100 to this, so it becomes 4300. So the next address, base address is 4300. So here the segment 2 has to be stored and the size of that segment is 400. Just add 400 to this 4300. So then it becomes 4700. So next look, minimum is 4700. So already it is there. So just add segment 4. What is the size of this segment 4? That is the 1000. So just add 1000 to this. It becomes 5000. So the starting address is 4700 and ending of that segment is 5700. So next size is 6300. So write somewhere here 6300 and this is the segment 1. So the limit is 400. So just add 400 to this 6700. So this is how each segment will be stored in the physical memory. So adding the limit and the base, so which is present in the segment table, so then it's stored in the physical memory. So let me explain the segmentation hardware, so that I'll explain the next video also with a simple example. So taking some segmentation hardware. Thank you.